Welcome to Learner's Planet, our theory session 4 of acids, bases and salts. So till now we have discussed about the chemical properties of acids. In this session we will be discussing about the chemical properties of bases as well as about the pH. What is the pH and what is the pH scale? So now let's start with bases. So what are bases? Bases are, in general, we say that those compounds which release hydroxide ions in solution are what? Bases. Now here there is Arrhenius definition of base, and it is: a base is a substance which dissolves in water to produce hydroxide ions in solution. So students, it is any substance which dissolves in water and produces hydroxide ions. The characteristic property of a base is due to the presence of these negatively charged hydroxyl ions. Say for example, magnesium hydroxide is dissolved in water. What we will get? The magnesium ions, that is Mg2+, and the hydroxyl ions. So students, it is because of this hydroxyl ion a base has its basic property. Let's take a few properties of bases. The chemical properties of bases. Now what do bases do? What type of color they are giving with the litmus solution? So they convert what? They convert red litmus blue. Right? What type of color they are giving with the methyl orange? The bases or methyl orange gives what color in basic medium? It is giving yellow color in basic medium. And your phenolphthalein gives pink color in basic medium. Likewise your turmeric, which is a natural indicator, and it gives what color, students? It gives red color with the bases. If at all your washing powder is spilled over a cloth, or if a pinch of turmeric is spilled on your cloth, and if you are washing it with a detergent, it turns red. Right? So your bases gives blue color or change the color of litmus to blue. Now the chemical properties of bases. This is action of air on bases. What happens when bases are exposed to air? When exposed to air, alkalis. What are alkalis? What is the difference between a base and an alkali? A base which is soluble in water is called as alkali. So, when exposed to air, alkalis combine with carbon dioxide of air to form respective carbonate, like your sodium hydroxide. It is what? It is soluble in water. So we have taken what? Sodium hydroxide aqueous. When it is exposed to air, it combines with carbon dioxide and it forms what? It forms sodium carbonate and H2O. So what is a sodium carbonate? Sodium carbonate, when it is dissolved in water, what it will give? Do you have any idea when sodium carbonate will dissolve in water? Say there is sodium carbonate, Na2CO3, which is formed Na2CO3. Now when this is dissolved in H2O, what it is going to give? It will give 2NaOH and acid, that is H2CO3, that is carbonic acid. Right? So this is about this thing, sodium carbonate. Now let's see a few more bases over here. Your potassium hydroxide. Potassium hydroxide is a base. It's aqueous solution. It means this potassium hydroxide is soluble in water. So it will be called as what? Alkali. Now potassium hydroxide reacts with carbon dioxide, giving what? Again the potassium carbonate and water. Do remember these reactions, students. Here your calcium hydroxide reacts with carbon dioxide, giving carbon dioxide, calcium carbonate and water. You know what happens? What are you taking for painting the walls? We have discussed this in the chemical reactions and equations. We are taking quicklime or calcium oxide. Now when it is dissolved in water, it is forming calcium hydroxide, which is the slate lime, and it is painted on the walls. Now when this slate lime or this calcium hydroxide is exposed to air, it reacts with its carbon dioxide and forms calcium carbonate, due to which the walls of houses have got shiny texture. So these are the bases. In general, the bases, what can be the general equation here? It can be the bases reacts with carbon dioxide and form what? Their respective carbonates and water. Now we've got another property, action of bases with ammonium salts. Alkalis combine with ammonium salts like ammonium chloride, ammonium sulfate, ammonium carbonate, forming their respective salts and ammonia. So alkali reacts with ammonium salt, it gives salt, water and ammonia. That is, what is an alkali here? Calcium hydroxide. It reacts with what? Ammonium salt. It can be ammonium chloride or ammonium sulfate or ammonia carbonate. And it forms what? Calcium chloride. And water and ammonia is given out. Let's take it one more example here. See, the another base, that is sodium hydroxide, reacts with ammonium sulfate, forming sodium sulfate, ammonia and water. So the sodium hydroxide is reacting with ammonium sulfate, forming what? Sodium sulfate, water and ammonia. Students, it can be ammonium carbonate also. So if I am taking your potassium hydroxide here, that is KOH, and I am treating this with ammonium carbonate and H4 whole twice CO3, then what am I going to get? I will get here potassium carbonate K2CO3 plus of H2O, that is the liquid, plus of ammonia, that is NH3. So with the on reaction with ammonium carbonate, we are getting what? The respective salt and water and ammonia are given out. So this is the reaction of bases with ammonium salts. Now this is a very common reaction, that is the action of base with acid. What it is called? The reaction of a base with an acid, it is what? It is neutralization. That is, it forms when the acids react with bases, they form their respective salt and water. So what is happening here? It is base plus acid is giving what? Salt and water. So what is the base here? It is KOH, that is potassium hydroxide. It is reacting with sulfuric acid and it is forming what? K2SO4, that is potassium sulfate and water. So what is salt here? It is potassium sulfate. So if I am taking another as base, that is NH4OH is again a base. It is reacting with an acid HCl and will form what? It will form the respective salt. What is the salt here, students? It is NH4Cl. plus of H2O. So you can take any base. I can take here calcium hydroxide also. And I can treat it with HNO3. So what I'm going to get here, I'll get calcium nitrate plus H2O. Right? So it is whenever an acid reacts with a base, what is formed is a salt plus water. So there is a neutralization reaction. Actually, the neutralization reaction is summarized as a reaction between H plus OH minus giving what? Giving water. H2O. So this is about the reaction of acids or the bases with acids. This is your NaOH reacting with hydrochloric acid, forming what? Sodium chloride and water, that is a salt. Ammonium hydroxide, that is NH4OH, reacting with phosphoric acid, that is H3PO4, giving ammonium phosphate and water. So whenever a base reacts with an acid, we are getting the salt as well as water. Now we've got the pH scale. So what is this pH? pH is, that is, the strength of acids and bases can be expressed in terms of the concentration of hydronium ions or hydroxyl ions in solution. Concentration means, say, the concentration of hydronium ions or H plus. It cannot exist, so it exists in water as H3O plus ions. It is given in moles per ml or moles per liter. Right? So it is in moles per liter. Now, pH. P in pH stands for potence. Now what is this potence? Potence is potential in German, potential or the strength. Right? So P is for potence, that is in German. pH of a solution is the magnitude of negative power to which 10 must be raised to express the hydrogen ion concentration of solution in moles per liter. See, that is pH is equal to 10 to the power minus X. Right? So this X is what? This X is the concentration of H plus ions or H plus in what? In moles per liter. So if the concentration of hydrogen ions is 2, so what will be the pH equal to? pH is what? It is the magnitude of the negative power to which 10 must be raised. If the concentration in moles per liter is 10 to the power minus 2. So what will be the pH? It will be 2. What is pH? pH of a solution is the magnitude of negative power to which 10 must be raised to express the hydrogen ion concentration of solution in moles per liter. So if pH is 3, so what will be the hydrogen ion concentration? It should be 10 to the power minus 3 moles per liter. Now, the pH of neutral solution or water as hydrogen ion concentration is equal to 10 to the power minus 7. So it should be, students, 10 to the power minus 7. So what is the hydrogen ion concentration equal to? The H ion concentration is equal to 10 to the power minus 7. Then what will be the pH equal to? 7. The same case, the pH of acidic solution, as H plus ion concentration, I'll write it correctly, it should be H plus ion concentration is less than 10 to the power minus 7 moles per liter. Say, if the hydrogen ion concentration or H plus concentration is equal to 10 to the power minus 3, so what will be the pH here? 3. If it's 10 to the power minus 2, then what would be the pH? It would be 2. Right? So for acidic solutions, what is the pH? It's 3 or 2 or 4 or 5. That is less than how much? It is less than 7. Likewise, pH of a basic solution as hydrogen ion concentration is more than 10 to the power minus 7 moles per liter. So that is, the pH would be what? pH would be more than 7. It should be 8, it should be 9. Now let's see the pH of some or a few important or some common substances. Like here, if I write the concentrated sulfuric or hydrochloric acid, so what would be its pH? It should be 0. Now what is the pH of dilute hydrochloric acid? It comes out to be 1. If I talk of your digestive system, that is the pH in the stomach, or the pH, I'll write it as pH of digestive juices. So the digestive juices here, what is the pH? The digestive juice in the stomach, students, HCl is present, that is hydrochloric acid is present. Now it is required for maintaining the acidic pH of stomach. Why? Because so that, or it is required for the optimum activity of the pepsin enzyme which is present in the stomach. Okay, so the pH of the stomach is around 1.4 to 2. So what would be the hydrogen ion concentration? It would be 10 to the power minus 2 moles per liter. Likewise, the pH of intestine, where the enzyme like your trypsin is present. So, the pH is in alkaline range. That is, it is around 8 to 9 or to 10 also. Likewise, the pH of saliva. What is saliva? What type of enzyme is present in the saliva? It is amylase. Now, what is the function of amylase? This amylase digests carbohydrates. This cleaves long chain of carbohydrates into the smaller ones. So it is amylase, and what will be the pH? It is before means. Before means the pH is 7.4 and it is saliva. After means what will happen? After means the pH reduces because the hydrogen ion concentration increases. Now after meals it is 5.8. So the pH comes, or the mouth is in the acidic region, the saliva becomes acidic. Now this is the reason why you have got in your teeth, the teeth is composed of, or teeth is made up of calcium phosphate. Now when the medium becomes acidic, the dentine starts dissolving out. It reacts with the acid and forms the compound. So it starts getting dissolving out. So that is why it is advised to just use mouthwashes or the chewing gums, or to use toothpaste which have alkaline pH, so that the saliva again comes to the neutral range. Otherwise, if your mouth is in acidic range for a long period, the teeth or the dentine, which is composed of calcium phosphate, will start getting deteriorating or getting degrading or getting dissolved, right? So there are, what is the pH of blood, students? The pH of blood is 7.4. Now it has to be in neutral range because most of the enzymes have their optimum pH in the neutral range. Likewise, what should be the pH of toothpaste? As I told you that after eating, the pH of mouth comes in acidic range. Now that acid destroys the dentine. So the toothpaste should be in the alkaline range, that is, it should be 0. Right? Now what should be the pH of Digen or your Aciloc or any substance which you are using for reducing acidity? Say I am writing as Aciloc. What will be its function? Aciloc is a medicine used to reduce acidity. So it will go in the stomach, and what it will do, it will reduce the acidity, or it will react with the acids, excess acids. Most of the antacids contain milk of magnesia. And what is milk of magnesia? Milk of magnesia is MgOH twice. So this is what is milk of magnesia. Now, what should be its pH range? It should be above 7, right? So it should be more than 7. So can you suggest the pH of washing soda solution? What should be the pH of washing soda solution? It is alkaline, it is strong alkali. So what should be its pH? It should be 9 to 10 range, right? So these are the pH of some common things. Now students, we have done indicators. Do you remember? But indicators, what they do? Indicators, they just tell whether the given solution is acidic or basic. That's it. Do they tell what is how much acidic or the strength of the acidic or basic nature, or what is the pH of it? No. Now there is one more indicator, that is universal indicator. What it tells is this particular indicator, students, it tells the pH of the substance. It consists of a strip. In that strip are the different levels marked, and it gives different colors at different pH. Say there is 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. Now this gives different colors at different pH. Like, it gives red color in concentrated HCl. So that is concentrated HCl, it is going to give red color. So the pH here becomes what? pH is equal to 0. Likewise with dilute HCl, it gives orange color and the pH is equal to 4. Under the neutral conditions, so likewise it can give different colors. Under the neutral conditions, what it is going to give? It gives green color. Right? So there is neutral solution, your universal indicator paper is giving green color. That is pH is equal to 7. In alkaline conditions, what color it will produce? It produces in, say, mild alkali. That is, the bases which are soluble in water are called as alkali. So with mild alkali, it gives blue color, and the pH will be approximately around 8 to 9. Whereas in strong alkali, strong base, the color will be violet. So such sort of strips are provided with the soaps. These days the soap companies, they are also providing such sort of pH strips. They are given to the farmers so that they can check whether their soil is acidic or basic and can do the required treatments. So that soap, you must have seen the ad of Dove soap. There is indicator of a strip is shown which tells the acidic or the alkaline nature of the soap. So this is about pH. Now in our next session, students, we will be doing about the preparation of salts, preparation and properties of salts like sodium chloride, sodium hydroxide, or washing soda, or the baking powder, right? So thank you very much for listening patiently, and have a nice time ahead.